Today is Tuesday. Yeah. So yesterday we talked about what are smart contract, and we saw the historical background of smart contract. That smart contracts were actually developed all proposed in 1994 by Nick Szabon, and he had also created or invented a virtual currency called Bitcoin Gold in 1998, fully before, like 10 years before the invention of Bitcoin. So we also saw that smart contracts are programs, they are simply programs that runs on the Ethereum blockchain, and it's a collection of code, that is functions, and data. Data is the state that is decides a specific address on the Ethereum blockchain. We also talked about the benefit of smart contracts, and one is benefit of smart contracts is transparency, efficiency, and then we have cost reduction, and we have security, and we also did compose. We talked about the composability of smart contracts. That is, smart contract can be thought of as open APIs. They are open to public, because basically when you're writing RESTful APIs, the returning, or the words that not the words, but the output of your program is normally in JSON format, and the same case for our smart contract. The output is normally in JSON format. It's always in JSON format. Yeah. So that was on composability. So today I wanted us to look the differences between traditional smart contract and traditional contracts and smart contracts. That's something that has always, like, it's always confusing. Traditional contracts and current smart contracts. So yeah, I'll share the other slide. Should be. Let me see this one. Yeah, this one. Yeah. So first of all, we talked about the traditional smart contracts. One, having like the execution is done by the lawyers, or it's done by the lawyer. They actually execute the laws in the contract. It's always a paper contract. It's always a paper contract. And then interaction between humans and object, possible application for like punishment, definition can be interpreted like a trial. And then we have semi-manual data, the correction, that is the audit of the contract. So you can, at the end of the day, the contract has a trial and punishment, and it's a paper contract, and now it has to be audited by the auditors or the lawyers themselves. Then we have the smart contract. So a smart contract, the execution is done by the EVM, or the Ethereum virtual machine. It's a program execution, only one interpretation, and it's not reversible. It's autonomous. It's autonomous, meaning that it automatically performs that task that it has been given. Real-time immutability. So there is real-time immutability of data. And then we have the definition of the contract is a software program. It's a software program. Yeah. So that is a major difference. See the other slide. The slide. So, as from what we saw, a smart contract is, these are diagram like explaining what a smart contract is. So these are diagram explaining how a traditional showing how a traditional a contract and the difference between us. So these are an image illustrating a smart contract versus a traditional contract. So basically, we want to like create an agreement between two parties. One could be the buyer, the other one could be the seller, and they are selling a land. So you need the third party. The third parties are the lawyers. So every party comes up with a lawyer. And then the agreement is written on a paper. So both side A or side B, they come up with an agreement that this is what we will sell at this particular at this amount of money. But now with smart contract, the third party is actually removed. The third party of the contract is removed. That is the lawyer. You wouldn't like need the lawyer to actually make the contract to be fulfilled. So that is the work of a smart contract in a diagram. Then the other slide will see the traditional contract versus smart contract. And traditional contracts, we need government, we need lawyers, we need auditors, and we need a lot of other third parties in our contract to like actually enforce. There is a lot of procedures that are followed. There is a lot of procedures that are followed. The same case, if you store your money in the bank, there is a lot of procedure that is followed. When you are trying to withdraw, you have to sign. You have to sign. You have to do your due diligence, of which sometimes it's you have to queue lines, of which sometimes it's a tedious thing to do, and it's your money. But for smart contract, there is no need for all those third parties. The other one is that execution time takes 1 to 3 days. So for a contract to be signed, it can even take like months if something goes wrong for the contract to be executed. Yeah, like the government tenders. You have to go the process of approval, verification. No, before you go to approval or approved, you have to like submit the documents of your company and show that this is what you have been making as a company, all those stuffs. And then you have to go through that is the verification process. Then you have to go auditing, and then you have to go through the approval. And then before the approval of money is actually done, it's already 1 month. Yeah. But for smart contracts and for information systems, if you create an information system based on blockchain, all those records are there. So for you, if you're doing a verification process, if you are the clerk of or the tender provider, or the one who is providing the tender, uh, you will just go to the smart contract, check what they have been doing as a company, and see all the records there. The audit is open because the data is immutable. unlike these other paperwork, which involves a lot of paperwork, and sometimes paper can be maybe misplaced. So that is the execution time. Then we have remittance. So remittance is a manual process. That is the payment. It's usually a manual process. The process is automatic. So once you have fulfilled all the requirements of the smart contracts, so if you're eligible to like crowdfund, if you have actually verified your KYC, if you're if you meet all the requirements, the process will be automatic once you have been verified. Then we, on the other side, the process is manual, because now that money has to be deposited into your bank, and the bank notify that this is, all those government processes when you are acquiring a tender, or any process, or any for like the NGOs. That process is a tedious job. Then we have transparency. For traditional smart contract, transparency is not available. It's not available. So the same case for the government tenders, which are done. Some of these government tenders do not have transparency. They don't have transparency. Yeah. So you find that somebody was allocated like millions of money or billions of money, but there is no transparency. There is no way to track whether this project was actually done. There is no way to prove that this particular tender was worth this amount of money. Then for audit and transparency in a smart contract, it's available. So you're able to like track what people have been doing. Yeah. You don't even need for public blockchains. You don't even need to like ask the heads of, or the head of finance to like give you access to ledgers. You don't need to like ask the head of finance to give you access to the Ethereum blockchain, because it's readily available for audit and scrutiny. Yeah. Then we have the archiving is very difficult, like the store, how they store information, because at one particular time in history, if you really like watch a lot of or if you read a lot, I remember somebody called Pablo Escobar. One time he went and burnt the entire the entire court of Corubia, because because of evidence that the court had on him. So he burnt, and then the evidence was lost. So now you can imagine the loss that they had compiled a whole case about somebody, and then in one day all that record is burnt. So archiving and storage for traditional contracts. So yeah, you can imagine an entire evidence or an entire courtroom being burnt, or all the way some schools get burnt during strikes, and then the entire document of student is lost. See, so saving this kind of information is very difficult, and very uh, the condition they store them is so the way they store data is the way a traditional contract is stored, or the way people in different organizations store data is difficult. Uh, then we have smart contracts. The storage of data, as you can remember, it's immutable. One thing, it's immutable, and it is dispersed, like it's dispersed or stored in different nodes of computers all over the world. So storage of data is easy, and if one node fails, like one computer fails, the other one won't fail. The other one won't fail. It is continuous. Normally, like uh yeah, since it's a chain of it's a chain it's a blockchain. Yeah, it's a blockchain. And if one chain fails, or if one node fails, then the other one will have the copy of the blockchain. The other one will also have the copy on information. Think of this: if you want to like if you want to store a secret, or if you want to store information, you disperse that information in your class. If I want like this information to be remembered, for example, if somebody who is not in this meeting owns me uh, owes me like 10 or 10 Kenya shillings, uh, then I'll come and tell you. Now you will be like you will be like the nodes. So if, in case I forget, one of you will remember. One of you will remember. So it's the same case for the nodes. So storing information is very easy on smart contract, and because of the immutability factor. Yeah. Then cryptography or encryption, it's very low, or security for traditional contract. It's very limited. For smart contract, it's secure because it uses cryptography. It uses cryptography, and we last week we saw the types of cryptography mechanisms that are available in blockchain. Well, the cost of traditional smart contract is expensive. So you can imagine the same scenario for buying a land for the seller and the buyer. So the buyer hires a lawyer, and the other one hires a lawyer, and they are just what they are just trying to do is they are just trying to buy and sell land, and they have to like other costs like for creation of the contract, creation of everything, the transfer of title deed. But if we had a smart contract that does that manages the land registry, and then I have a copy of my title deed on the blockchain, and I want to sell it, then there wouldn't be a lot of lawyers. There wouldn't be need of lawyers. We will only need to the guy will only need to transfer Bitcoins or Ethereum to me, and then the contract verifies that the guy has sent or funded the escrow, and then I transfer the ownership of the title deed, and then it's recorded, and then it's official. So the the transaction, and also the way they store data, makes it expensive for traditional contract. But the way data is stored in a smart contract, and the transactions initiated on a smart contract makes it cheaper. Then signatures and manual processes. So you will have to sign those manual processes for like withdraw and approval. So you find that sometimes so for the signature, like you find that maybe if you are still in the process of acquiring a tender. Sorry for that. So if you are still applying for a tender, or something like a scholarship or something, you sometimes find that the only remaining signature, or the most important signature, like that of a dean or that of the accountant to approve the release of funds, it's the only signature which is missing. And then they like tell you go come the next day, and the process continues. Like it's like a game, so the following day you go and find that the person who is supposed to sign for the approval of your release of your funds is not there, because the signatures are manual processes. But for smart contract, you don't need to like wait, because time is precious and you don't have to wait. So the digital signatures are lane built, and some of these digital signatures are cryptographic, like the private key. Yeah. So then so we already know what are smart contracts, and we saw the example of the vending machine. So consider a real life example where you are taking out a chocolate from a vending machine. So you deposit like a $2 note in a vending machine, and then after that you hit like a button A1, which is mapped against the chocolate bar that you want to buy. Then after that, the result is, as a result, a lever in the vending machine moves and pushes out the chocolate, and then you have your chocolate. So that is a smart contract. Is very similar to a vending machine. It eliminates the need of intermediary and escrow services. Escrow services is these escrow services can be inbuilt, like in the can be inbuilt for complex systems. We will see the the way local crypto works. But for like a vending machine, we don't really actually need a shopkeeper to be there. The vending machine already knows the where the chocolate bar is located and the cost of the chocolate bar. So when I deposit $2 on the onto the vending machine will automatically know, and then there wouldn't be a need of a person to be there. So if you own that vending machine, the only time you will come to withdraw your cash. So that's how smart contracts work. And then so smart contracts are self-executing contracts which contain the terms and condition of agreement between the peers. And then the terms and condition of an agreement is written in code. These agreements facilitate the exchange of money, shares, and property. It executes in blockchain's decentralized platform. Then we have to consider another example of where Rachel is at the airport and her flight is delayed. But these inconveniences could have been beneficial to Rachel, as smart contract insurance would ensure she is given a compensation for the flight delay. Yeah, so this is an example of where a smart contract can be used. And yeah, so if a flight is delayed, there is supposed to be a compensation for the flight delay on a smart contract. So there are guys who are trying to come up with such innovations. I don't remember. I don't remember the name of the company, but there were guys who are creating smart travel, whereby all your information is connected into a blockchain, and then there is use of Internet of Things, whereby you see the onboarding board, the board that is always located there at the airport, where you like check the flight time or the time. Now, instead of that board, you have a mirror screen. It's called parallel something, parallel view. Let me see parallel view. It's called parallel something, whereby we can actually be looking at the same screen. We can be looking at the same screen, but I'm seeing my information and the flight details of my flight, and then the other person is looking at the same screen, and they can only see the details of their flight, the time of their flight, everything, but it's the same screen. So let me see if I can and then all that information is also connected to your device. Now, those are some of the things which are futuristic, and some of them are happening in places like Dubai, the smart cities. Yeah, it's just a matter of time we start seeing them here in Africa. Yeah. So that's another scenario where a smart contract can be used. And then we have, so AAX, flight delay is an insurance, one of the example of an Ethereum smart contract. And the smart contract is linked to the database that records flight status. And then it enables automatic compensation when there is a delay for 2 hours or more. So this is a good because it actually makes people trust the airline or the insurance more, because if there is guarantee for compensation without having to like go to the physical company, to claim for your insurance because of the delay of your flight, then this is good because you won't waste a lot of time. You will be able to go on with your own with other businesses. So that's a use case. Now the breakdown of the smart contract. A smart contract is created based on the terms and conditions. So we have one condition. The first condition is and this will now be the basis of our function, of most of our functions in a smart contract. So the first contract is that we need compensation if there is a flight delay that is less a delay of 2 hours. So we need a compensation when there is a delay of 2 or more hours. This one should be the other way. Delay of greater or equals to 2 hours. Then we have based on the code, based on the codation that we have created. Based on the code, smart contract holds the company's money until a certain condition is satisfied. So this condition has to be satisfied. Has there been a delay of 2 hours? If there is no delay for 2 hours, then the company, the smart contract won't release the cash. But if there has been a delay of, if the condition is true, then the company actually releases the funds. Then we have this smart contract is submitted to the node on the Ethereum virtual machine for evaluation. And yeah, so EVM, as what we saw last week, is a runtime compiler to execute smart contracts into bitcodes. Sorry. Yeah, so next slide, all node of the network executing the code using the EVM must come to the same result. They have to agree that this is what, that the time delay or the flight delay was actually true, and they have to show that this is the information that we gathered, and this is what we came with. These are the results. So that is the proof of work. Then, if the flight is delayed for 2 or more hours, smart contract will be self-executed and a compensation amount will be given to Rachel. So smart contracts are immutable, so they won't let any person to alter the agreement that Rachel has with the AAA insurance company. So that was a smart contract. So yesterday we talked about, we also talked about Solidity. And we said we actually never talked about Solidity that much in depth, but Solidity is a high level programming language. So these are some of the important questions. So what programming language does a smart contract use? And that is Solidity. And just a minute. So as what I said yesterday, Solidity was created by Dr. Gavin Wood, and it's a combination of C plus and C plus and JavaScript. So that's why it's a high level language. They actually had to come up with a language for creating smart contracts, and with features to directly support the execution in the decentralized environment of the Ethereum world computer. So that's why they came up with this language. So Solidity, we have like two languages. So we have one which is Solidity, which is a Java-like JavaScript-like kind of language, and then we have some Serpent or Viper. I don't know whether they changed it to I think they changed it into Viper. Into Viper. I think they changed it into Viper. But they kind of mean the same. A Viper or a Serpent, it's a snake. It's a Pythonic language. It's a Pythonic language. It has, if you know Python, Python are like simple English sentences. So they are the two widely used programming languages for writing Ethereum smart contract. So Solidity and Serpent are the most commonly used, but for Solidity has a wider community. So I normally use Solidity for my case because there is a lot of community based, and then when you have a problem, you can actually find a lot of solutions on the internet because Solidity has a wider community. Then right. So however, on blockchain platforms, Solidity is widely used for implementing smart contract, like I have said, and this is the symbol for Solidity. And then so Solidity, as I have said, is a high-level programming language used for implementing smart contract. It enables to check the program at runtime rather than compile time. So every time the program is running, compile time is when you are like compiling the program so that all those functions are consolidated into one. But runtime is when the program is actually executing. And this program enables you to do those checks when the program is actually being executed. That is one advantage of Solidity. So we'll talk about advantages of smart contract in real world, and we also talked about the benefit of uh, smart contract, but yeah, there is an advantage, and it's the same thing as the transparency and no intermediaries or no boundaries. Yeah, so these are some of the advantages of a smart contract. So one, there is no intermediary. The process executes without the need of a third party. The other one is the process is automated. They are automated with the code, which eliminates manual effort for execution. Then we have they perform at a high speed. Since smart contract run on programming code, the speed of its execution is higher than the traditional contract. And then we have it's secure. It's secure as data is stored in the decentralized system. The chances of modifying data is difficult, and also it's accurate or accuracy based on the requirements, terms and condition of a contract is recorded accurately. Then that's it on advantages of blockchain. So what are the other have we can be able to like do? So this will be from 6:30 to 7:30. Yeah. If it's okay, we can try and do some we try and do some another exercise on smart contract. Yeah. Hello. Hello.
Yeah, it's okay. We are with you.
Yeah. Yeah. So
Yeah,
am I supposed?
but one question, yeah.
Yes.
The in writing a smart contract, you use either your Serpent or Solidity.
Yeah. Yeah.
I mean, which one is more rugged? Because definitely, I want to believe that one of the programming language will be more rugged than the other. I mean, that's why people tend to use Solidity more than using the other one.
Okay. One is Solidity is very simple. Solidity, I would say it's very simple. I've actually never I've actually never took time to like learn Serpent or the Pythonic. Yet I started coding with Python. Uh, I when I started my programming, I started with Python, but when I started doing smart contract, I realized that JavaScript was a bit simple, and materials for Solidity or access it Solidity. Excuse.
Hello.
Hello.
Will the exercise involve direct participation?
Yeah, we can have a direct participation.
Okay. I'm requesting, can we begin at 7? I'm on my way from Renessike so that I can be active as well.
Okay. Then we can move it to 7 then.
And I have a question.
Yes.
I've been saying, let's say I have Bitcoin and I'm sending, and accidentally I copy an Ethereum wallet.
Yes.
Those coins they never, I think they said they get lost.
Well,
What
if if you accidentally send bitcoins to an Ethereum wallet, yeah?
Yes, or to send maybe you send any other token that is not ERC20 to an ERC20 wallet.
Okay. So it should revert. It should actually revert. It should go back because the transaction shouldn't go through because those are not. They are two different. They are two different. They are two different networks. Unless there is an oracle that has actually made the transaction go through, or there is something, then it means that your Bitcoin will be sent to that wallet. But it should revert most of the time. If you are sending to the long address, or if it should actually revert if the condition is not meant, it should actually revert.
And are we not violating immutability?
Reverting means that it goes back to your wallet. It goes back to your wallet. The process should not go through. Like, let's say, from what we have had, there are conditions that are supposed to be met. So one thing is that that coin is not it's not an ERC20 token, and it doesn't belong to the Ethereum network. If it doesn't belong to the Ethereum network, then that transaction shouldn't go through. That transaction shouldn't happen. It should revert back to your wallet. It should revert back to your wallet.
Okay. So let's say if you're sending it should not even revert. It's not even supposed to go because it has to tell you it's the wrong network.
Like a good example is like if you try to a long time ago, if you try to like send money like M-Pesa to Airtel Money, so there was sometimes you couldn't be able to do such a transaction. You couldn't do such a transaction because those are two different networks, unless that's when now they created the till number that you can be able to send to Airtel Money through a till number that is an M-Pesa number, and then from that they transfer that money to that account. Yeah, those are the work of oracles and bridges. Yeah, so if such a transaction goes through, then it means that the wallets have been it shouldn't actually go. It shouldn't go. Yeah. Yeah. So then there was the other question for. I hope that has answered your question.
Yes.
Yeah. So the other question Ambrose had asked is about the languages, the two languages. So one is okay, I don't know, but it depends. Because for me, I fell in love with Solidity because one, there is a community, and then it's simple. It's simple because it's simple. The way you implement it's easy to understand what you are doing with Solidity. But For Serpent or the Pythonic one, there is less community, because sometimes I go with the community, because I go with the community and the steepness or the learning curve. If the learning curve is very hard for me for new programming, then I move on to another one. Before that was in 20, I think it was in 2016. I started learning PHP. The learning curve for PHP was very steep, because and every time you are learning PHP, there was a new PHP version which was coming, so you have to now learn the new syntax. So it kept on changing with a lot of changes. So that is something that I also look at, the learning curve. If the learning curve is very steep, and also the community, if there are no resources, there is no a lot of resources to actually learn the language, then you will have to move. That's the kind of joke that in programming they make. If you go on Stack Overflow and then you are not able to find the solution, then you will have to revert or change. You will have to change the entire code base of your program, so that you can use a programming language that has a community based and that actually solves that particular error. Yeah, so I went with Solidity because we have a lot of developers who are doing in Solidity, and it's well maintained Solidity than Python, though the Serpent one also in blockchain like Neon, you will need to use Serpent for users who have already like done Python or Brownie, who want to use Brownie as their framework. Then they can use Serpent to create and develop smart contract. Yeah. So it depends with what you are able to like grasp very fast, or what you are able to understand very fast. But for my case, I'll be using Solidity. Yeah. So we'll be using Solidity and Trafo, and yeah, as our framework. So let's just wait for let's continue. Then we start the practical session on at 7. Yeah, if that's okay with you, nowadays, with you. Yeah.
Yeah, that's okay.
Okay. I hope that has also answered your question, Ambrose.
Yes.
Yeah. Okay.
Let me ask.
Yes.
We said EVM powered by gas.
Yeah.
Right.
Yeah.
And now this gas you pay with paper.
Yeah. So
is there now when you're deploying a contract, you say you pay with Ethereum. Is there a way you can pay with any other Ethereum-based token?
Is there a way you can deploy using another Ethereum token?
Yes.
No, you can't. Ethereum or ETH is the native coin for interacting.
Why?
Now, yes. Hello.
Why is it only Ethereum can be used?
Well, the reason why it's because it's you are accessing the Ethereum platform or the Ethereum. Now, picture this. You want people to like you created an ecosystem of resources, or the arcade. Yeah. Let's just use the example of an arcade or a casino. So you have all these services that you are offering in your casino or arcade. but you want people to access these services, and you want your services, since your services are unique, you give them chips. You give those people casino chips. Those casino chips are actually for accessing all the services, that are available in your casino. And that's what normally happens. So if you want to actually leave that ecosystem, you will have to exchange those chips, so that you get the real cash. So ETH is the native coin that has been created which has been created in the Ethereum ecosystem. So to access all the services that Ethereum is providing, you will have to use that native coin, because this other coin has not been yet been created. They were not yet created. If you now have your own blockchain, like Binance chain, they use the is it BNB? Yeah, BNB. They use BNB to deploy. They use the native coin for the Binance smart chain to deploy the smart contract. The same for Zero. The same for Zero. So you cannot use another coin unless you have your own blockchain. That's when you now can have to use your coin. You have to create like a native coin for your blockchain. Yeah. So hope that it has been cleared. Yeah, is clear.
I guess it's clear. So it means that even in the, let's say, Celo, you
Yeah.
use the native token.
Yeah. They will use the native token, that is the Zero.
Okay, understood.
Yeah. Uh, let's see. So that's the reason why they create native coin, because they are offering services, and that's what also makes the blockchain to grow, the need of the use case of the coin. Yeah. So let's just continue. So we have blockchain implementation of smart contracts. So using blockchain implementation of a smart contract. So we look at another example, and that is the using blockchain in voting process can eliminate malpractices. So we take a look at a centralized voting process. So a centralized voting system faces a lot of problems when it comes to tracking of votes. So a smart contract is introduced to eliminate the malpractices of that particular vote, or that whichever vote ballot or voting process you are using. So then the terms and conditions are set in the contract. So terms and conditions are like each ID should be attributed to just one vote. So each participant of the voters the vote should be attributed to one voter. And if that voter comes again to vote, then the system declines them to vote again. Then we have the validation is done by the users on the blockchain network. The results, every voter vote gets recorded to the ledger, and the information cannot be modified. So once the vote has been casted, then that ledger cannot be modified. And let me show you a demo of this. So should be Okay, I'll show you the demo on the Remix IDE. I'll show you the demo on the Remix IDE. Let's just focus on another example, that is implementation of a smart contract in a hospital payment process. And yeah, this one can also be like modified to a further height, adding the patient hospital records. Yeah. So using blockchain in a hospital can ease the payment process. So consider an example where an individual who purchases health insurance is undergoing treatment. And the terms and conditions are also set. So set up a smart contract with an insurance policy and place it on the blockchain. Then we light when required, smart contract will be triggered by itself. And then as a result, the required amount of payment from the insurance company to the hospital will be made automatically. So there is no process there is no manual process that will be followed, and then it will be automatic, because we have had issues with insurance when it comes to hospital payment. Yeah. And sometimes they don't even like actually fulfill the amount of payment that you have actually contributed to the insurance. Then this one will have a demo. Then we have another use case that is for crowdfunding smart contracts. So crowdfunding is whereby people pull up or come up together and they do funding. They do funding like for a particular goal. Like let's say you are creating a hospital, or you are creating a company. People now contribute, they crowdfund your project. So we can create and one thing that has happened in the previous year, like in the Kickstarter. So people would do this. They would create a crowdfunding, and then the managers of that crowdfunding withdraw money and they get lost with it. They withdraw money and get lost with it. So crowdfunding was introduced so that people can be able to like see the amount of money that has been raised, and then a group of managers or people are selected to like actually manage the crowdfunding addresses. Let's just use an example. So suppose you want to start a business, then a lot of funding is required. So for such problems, smart contract plays a major role. But who would lend money to someone they don't trust? That's the biggest question. And a project, the project can be actually good, but they don't really trust the person. They think that that person can be a scammer. So with Ethereum, we can build a smart contract that will hold a contributor's funds unless a given date or goal is met. But who would lend money? But based on the result, the funds will be released to the contract owners or will be sent back to the contributors if the amount of money. So once there is two conditions. So there is the date condition, that is the time condition, and then there is also the maximum goal that is in that particular contract. So you will need to set the date when the goal. So unless a given date or a given goal is met. So let's say we want to raise like 10,000 US dollars. That's approximately 1 million, $10,000. So you will need to like, that is the goal. And then our timeline is maybe the end of September. By the end of September, we want to have raised 1 million Kenya shillings. So we have a goal. If a goal is met before the end of September, let's say mid-September, that money can now be withdrawn. If the date arrives and we haven't been able to like raise enough funds or we haven't met our goal to raise 1 million, then the money that has been raised, since the goal has not been met, it can either be returned back to the contributors, or it can be released to the contract owner. For the first goal, it's the same case. So centralized crowdfunding system have a lot of or have plenty of issues with management systems. And this is what I was talking about. Like you would like Kickstarter, you would create an account on Kickstarter and do a crowdfunding, and then once you have done a crowdfunding, the management or the managers of that crowdfunding get lost with the money. So for this particular problem, we will utilize a DAO. So a DAO is utilized for crowdfunding. Terms and conditions are set in the contract. Every individual participating in the crowdfunding is given a token. So every contribution gets recorded on the blockchain. So you create the crowdfunding way, you deposit your cash in exchange for a token. Let's say we want to create a crowdfunding for our blockchain class. So we will create an ADS token. So this ADS token will be given to the participant of the crowdfunding as a measure or a guarantee to hold that once they have contributed to our blockchain class, they will be able to like get returns with the token. Like the token now becomes the share. The token becomes now the share. They will have a share of the class, and then the money we have used, if we don't, if we do not use the money that they have given us as intended, then we can return that money and they give us the token. They will still not lose. They will still also not lose their money. So these are the key takeaways of our lesson today. So we have learned about the differences between smart contracts, traditional smart contracts. We have seen what is a smart contract. We have also talked about advantages of smart contracts. And then we have seen blockchain implementation of smart contract, and we have also seen different use cases. That is the voting process, the hospital payment process, and also we have seen on crowdfunding. So most of the crowdfunding or the companies that came before companies that around 2018, 2017, and 16, there was a boom on creating ICOs and crowdfunding. And yeah, ICOs, ICO, initial coin offer, pre-sale, blacklisting, and whitelisting. All of them, these are the creation of a crowdfunding process is a big process. It's a big process, and it involves a set of stages. Let me show you something. The Barrot demo. Yeah, this one. So this is the Barrot demo of the smart contract for voting process. And let me just deploy it here. Link Bay. Check if I'm in Link Bay. And I'm in Link Bay. Yep. So let me deploy this one, the Barrot one, and so that we can be able to like see the process. So here you have to like put an array of or a list of people who will be participating the proposals. So we'll have and then comma, we'll have then we'll have and then we will do it at that particular address. So the proposals have to be set before you start the so proposals, I think they are 3. And vote count, it's still nil. I want to see the okay. So these are some of the conditions that we were talking about, the terms and conditions of the smart contract. So for this particular ballot, it's implementing the voting process along with vote delegation. So we have the struct for voting. We have the struct for voting. So you will need the weight. Weight is accumulated by delegation, and then vote. It's either voted. It's a boolean, which is either true or false. And then we have address that is delegated, person delegated to that particular address, and then we have unit. Unit vote, that is index of the voted proposal, the person who has been voted, and then we have the proposal. So if you can limit the length to a certain number of bytes, so the name should be short up to 32 characters or 32 bytes, and then the vote that particular proposal has accumulated. Then we have the address of the chairman, and we have the mappings of the addresses of the voters, and then we have a constructor. So those are some of the variables that we need, and the boolean that is either true or false. So if somebody has voted, we need to know whether they have voted, and if they haven't yet voted, then the boolean will return a false value. So then we will have the constructor. So we'll have the constructor. These one constructors are with a parameter and a memory of the proposal names. This one proposal name. So which will be appended together with the name and the vote count. So then we have the getter. So give this particular address to the right to vote. And only chairperson can give right to vote. So the person here, the chairperson, we have like made this chairperson like message.sender. So message.sender, sometimes you can define the address of the chairperson like is equals to this, like that. Can actually do that, or just make sure that the message address, the message.sender is the one who has sent the contract, becomes the automatic person that for now it's zeros, it's 00. The address is is returning a 0 on the Genesis address. So we can give the voter right to vote, and only a chairperson can give that right. And then we have require. This one will return the voter already voted. So if they have already voted. And then we have function delegate. So delegate your vote to the voter, the parameters are like address to which vote is delegated. So you can self delegation is not allowed. If you have already voted, you cannot delegate it again. Found loop in delegation. So if there is a loop which has been found in the delegation of vote all, and then these the other conditions that we have. If voted, if the delegate already voted, directly add to the number of votes. So this is how you will add the proposal to the proposer together with the weight. And if the delegate did not vote yet, add her weight. Yeah, you will also need to do that so that you are able to track that the user has not voted. So the vote, give your vote, including votes delegated to you, to proposals name. So this one automatically, if the proposal is out of range of the array, this will automatically revert to the changes, so it will not go through. So our proposal, let's see that we can add our address there. No, we need to give the voter right to vote. So we have given the user the right to vote, and then we can vote the proposal. We want like proposal 1. Then we can confirm. So the transaction has gone, and it's displayed at the bottom here. So you can see the functions that we have invoked, the input that we have done. So okay, then we can try and now see if we can call this and see what value it will return. Okay. Not yet. Something that I did do. We didn't set the names. Just a minute. Okay. Let's see.
What exactly is the weight? What does it signify?
So the weight is the accumulated is accumulated by derivation, like see down here. So if we create a new, if we create only if you choose a name for the proposal name, that person is removed, is actually removed from voting, not from voting, but he becomes a part of the. Okay, I'm not sure.
Can you compare that, like, let's say when you see the chairman has more voting rights compared to other people in the lower rank?
The chairman is actually the one who is responsible for like just facilitating like the addition of new names, new proposals, just the proposal, adding the new proposals. But he doesn't have any voting rights, and yeah, he doesn't have any voting rights, because if you take a look here, the only thing that he has is to like, actually he doesn't have any other right apart from adding the proposals. He doesn't have any other right from these functions. He doesn't have any other right apart from adding proposals, because you will need somebody to like oversee the and also to, okay, there is this other one for giving light to people, so may only be called by chairman. That this is the only light he has. I think it shouldn't be. Shouldn't be. It shouldn't be. It shouldn't have. It shouldn't have. He shouldn't have that right to like to give people right to vote. But this one you can modify. It's a simple implementation. You can modify and put your own logic here and see what happens. And I think we are supposed to add the vote, the name only, the name. Yeah. Let's see if we. minute. This one should be proposal names. Hello.
Yeah,
Hello?
I'm with you. Yeah.
Okay. I'm saying. Okay. Just a minute. Just a minute. Supposed to be. My arguments are not correct. So let me see. Okay. Yeah, I'm using the long. It's the same way. Okay. Should be the addresses. Just like them here. The addresses, and then we have the other one. So 3 addresses. Then we have the last one. So there. Then we can now transact. Hmm? one. Let's see if it. Wow. But I don't know why it's not working. Okay. This is disappointing. Well, so I had prepared something here, and today I wanted to introduce on Solidity as we look for a solution for this one. Wanted to introduce on libraries and no, not libraries, but interfaces, interfaces, and interfaces are normally abstract of similar or similar to abstract contracts, are limited to what contracts represent. Contracts ABIs can represent. They have restrictions and cannot inherit other contracts or interfaces. So they cannot define, they can also not define a constructor and cannot define a variable, cannot define structs, and cannot define enums. That is the booleans, all options. So this one is a interface regulator. So this an interface is limited with just only functions. So these are simple interface, which is interface regulator, and it regulates the all it has two functions. That is function one to check value, and then the other one is for loan, and it returns a boolean. And this one, it returns a boolean value of with a unit of amount, and then they are inherited or are used in other contracts, like bank, the contract name, and then the one that you have imported, like this one, regulator. You can either create a separate folder for interfaces, and then call them like this. So bank, import them like this. So import regulator from regulator dot sol, depending with the folder, that the folder location you have, dot all dot for to refer another folder. So the interfaces are very important, because instead of functions that they can be reused in separate, in places, different places, then you can reuse them in other places. So like, let's say you want to add ownership of the contract into this contract, and then you also want to use the ownership in another contract, like to manage the 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 approval of funds, or the withdrawal of funds. So you have like an address that is doing a contract that is doing a different function, but you still want to like implement the same methods that you have in another contract. So that's why we come with interfaces. These ones you can be able to like reuse in different contracts. So I'll define I will create a smart contract. This one called a bank is contract bank, with a constructor for amount that we can deposit and withdraw, and also see the balance, and also check the balance from this function. Check the balance, and also get a loan, like kind of get a simple loan. Yeah. I'm not sure why this one failed, but let's just give it another try. So I'm thinking this is the way we should like input this data. If it doesn't work, you can go on to interfaces. Let's see. Let's just do the another contract. Let's just do another contract, and then in the meantime, I'll look how these contracts, why it's refusing to like add the card dates, because you need to like before you actually deploy the contract, you need to like set the proposal names of the users, the person who are vying for proposal. Yes, Ambrose.
Yes, I mean, in order to make life easy for everybody,
Yeah.
now that we're now into coding, writing, trying to write code for a simple contract,
Mhm.
why not take us through the process of maybe Solidity the interface there. From there, we just be going together. Maybe the way you are dropping it there, so that we're able to follow very well.
Okay.
It's not that one is not falling like this. Also, it will also make life easy for you.
Yeah, yeah, yeah,
You get the point?
yeah. I get the
Because
point.
right now, definitely, maybe the environment you are in right now change, and this thing you've written is running well, what in your system. So now you are now trying to bring it back to the real life, and it's giving a different error entirely. So maybe we can just start a fresh contract. We just see one, we run through it. Then from there, oh, this is working. This is the process. I mean, from there, it's like now what you are trying to do for us is we are doing the coding at the same time we are doing the debugging at the same time we are doing a lot of things together. So I don't know if you understand my point.
Yeah, yeah, yeah. I get your point. That's why I'm actually saying that we can actually do the another contract, because the other
Okay.
contract, so that from scratch, this one, the bank contract,
Exactly.
we define the a simple contract, and then tomorrow we do another one. Yeah,
Yeah, great.
yeah. So that we
That'll
can
be fine.
actually, yeah, so that we can actually see how different contracts work
Yes, great.
as we,
Yeah.
yeah, as we move on. Yeah, because
Yeah.
this one I wanted it to be a demo, a
Okay.
small demo, but my inputs, think there is something
Yeah.
wrong with the input.
No, it does happen. It's that's why it is called programming.
Yeah,
You know,
so
it does happen.
yeah, so I hope you were also able to like install
Yeah,
the
I installed
programs.
the Solidity, then but those the Ganache package,
Mhm.
you just take you into the website,
Mhm.
and I think there was something I had to install using npm install, but I think I did that. It's only
Okay,
Truffle that was showing a different thing.
okay, okay, okay.
Mm.
Okay. So I will hope you have also been able to like learn this or during your free time. This one,
Yes.
and you have been able to like see the different results, and how you can like actually be able to deploy using limits. Yeah.
No, I have not done that. What I just did was just to put it on my VS Code. I mean VS Virtual Studio editor.
Mhm.
I got the center. So now that I'm seeing what you are doing, I mean, right now I have to go to the remix.ethereum.org and put it there, and try to run it.
Okay.
Definitely after today's class, I'll try and work and try it out and let you know the outcome.
Okay. Okay. So this just a simple smart contract defining the various variable that we can have. So today we will do another simple contract that's a bank .sol. So bank.sol will be, oh, so bank.sol, it's the extension name, and then we will uh, so as we have compiled, it says that we don't have a license, so we will, as our custom, we will add our license up there. This one, a license. So you can actually copy and paste that one, and then you add. So then we need to like define our pragma. So because this we need to like identify the compiler version that we want to use. Yeah. So this is the pragma, the solidity version that we want to use. So we can paste it there, and then the code now does not throw any warning. So then we will define our contract. So these are keywords, as you can see, contract bank. And then remember the curly braces. Then from these curly braces, now we can okay, just minimize so that we have two screens. So we will define we will declare a variable uint. Yeah, uint it's normally 256 value. So you can just make it for, and then we will declare a constructor which will always return the amount of money. So it's also a uint 256 amount. Then it should return the value, this value that we have declared up here. So value will always be equals to our amount, and then we have a semicolon. Compiler failed with one. It should be public. Let me try and use the version that I was using, because I'm using 7, so that we don't have a lot of errors. So on this particular contract, I was using version 7. Yes. Oh, sorry. Then space. Then we will have a function to deposit with uint amount. So this is the amount that we want to make sure we want to and it should be publicly. Then inside the function, inside the function, we will have the value incremented. We will have plus equals amount. So this value will be incremented. So once we deposit, we will have to increment the amount. Identifier got okay, let me see. Okay, we don't have an error. Then we will add another function called function with the draw. So this one is a function to withdraw, and it will use the mathematical function or operators. That is the logic. They are called logic operators, and you need to know that minus equals that amount. So instead of like repeating this every time we want to withdraw, and every time we want to do a multiplication or an addition, we will introduce something called libraries tomorrow. Library called safe math. So safe math is used to you can import it here. Is used to help you in calculation. So you will just, if it's this, you will just call the function like this add dot value. We'll just use it like that, add dot value, and then you remove that multiplication. But since this one, this add is not there, if you want to multiply, you will use mu. So you see, it's actually makes your code look greener. It makes your code look greener. But for now, for simplifying thing, as Abros has said, let's use this method. Then it should the function withdraw will be public, and then the so we I won't use this function first of all. This one I won't use this function for now because we haven't created our interface. So I just want to like create a simple bank contract whereby you can be able to like add and yeah,
Okay.
add and try and withdraw. But this one should actually check the value of the amount that you want to withdraw. It should check the value. Should check the
Yeah,
value whether it's a
we
yes.
can put the value that will check the value since it's simple. Definitely going to bank, you also check what you have there before you can withdraw.
Yeah.
So you can also
So
put that. That should be an issue.
okay, then we will have our value, and it's minus, so it should be minus the amount that you have, and then that is the function. And then we will have, we should always return a balance. We should always be able to see the balance that remains in your wallet or in your bank account. So we will have another function, balance. It's a function. This one is provided. So with another thing, a very important thing is another interface called IERC20. It's an interface. It's already declares these functions. You don't like need to like repeat them. Just need to like call them and use them. So it should be public. Should be public view, and it should return a value of returns a value of integer 256. So it 256. Then we have that the value that should be returned. So return value, and then don't forget your semicolon. And then we have this other function for. So this one is a classic mistake under this tutorial is in the tutorial, value should be above the amount. So this function, the value should always be above the amount that you want to actually withdraw. So let's say you want to withdraw like 100 bob, but in your account you have a value of 10 bob. So the amount you want to withdraw should always be above, should always be above the value. So it should this actually, I think this is a mistake. The value should be above. Yeah, the value should be above. It should be greater or equals to the amount you are withdrawing. It should be greater or equals to the amount you are withdrawing. Because you shouldn't withdraw a lot of money when your bank account has less. Yeah. So that's the reason why we have the check. Yes. Hello.
Okay, let me ask where we have function, the function for deposits. The int represent integer.
Yeah.
And you?
UI is an assigned integer, it's an assigned
Okay.
integer, because currently right now you haven't assigned any value to it. You haven't assigned it any value. You have only allocated a memory where it will be stored, and it will be stored as an integer, which you haven't assigned. So there is assigned and unassigned, like this: assigned and unassigned. So this one you can assign a value, like let's say you int, but it's the same way you represent it. You int amount equals 200 or 2000, like that. So you see, you have actually assigned a value to it.
Okay.
But I've actually assigned it but I have assigned a value to it. So that one has a value in it, but this other one does not have any value. So this one should be 256. So 256. Then we'll have to add another function, this one called check value, to check whether you have enough amount of cash in your bank. So we'll have a function check value. So you notice that they kind of look the same, but this one has an override. It will override and return the value. Also, this one will override this one. So this one, since it's an interface, normally has functions that are external functions. External functions means that they can be used anywhere in other contracts. We have internal functions. Internal functions are functions that can only be performed within the smart contracts. So this one will override and somehow will override this one. And it should return a Boolean value if it's true. And then we have our value that we want it to return. You int amount. It should be public view override, and it returns a value which should be true. If you have that either true or false, if you have an amount that is equals to the value which is in your bank account, then so return value which is greater or equals to amount. Then we have a so function has but does not override anything. So it's not overriding anything because we haven't added this interface. So we will see in a while, but we can just remove the override so that we are able to see the differences. Then we have the last function, that is function loan, which is public view. Right now it's not overriding this one, but once we add the interface regulator, returns a value which is also a Boolean. Say that true. If you have a value which is greater than 0, you can be given a loan. Then So we have the value that it's supposed to be returned. Value should be greater than 0. So let's just try and run it and see how it works, or if it actually does what we have written. And there we go. So we have deployed our contract. Before we deploy our contract, we should actually add the value. So we will add like 1000 as a value, and then should confirm. Then we should have our second contract here. So if we try to get the balance, you see we have inputted an amount here of 1000. So if we get the balance, it should return 1000. It means that we have a balance of 1000. Then we can try and deposit some cash like 100, and then we deposit. Then we should be able to like confirm the deposit. And then once we should have something like 11 balance. Let's just wait the transaction to be mined. Just wait the transaction to be, the transaction has been confirmed. So if we get the balance, it should be 1100. Yeah, so our contract is doing as what we have actually created it to do. So let's try and withdraw something like 1200, and it should actually revert. It should actually revert. And it shouldn't go through. So the transaction should fail. That is just a minute. Let's see the reason why the transaction has actually, it's pending. The transaction is pending. Okay. Well, it has actually created a value which is not part of what we had. So this is what I was telling you about an overflow error. And this one is an overflow error because it has actually created an imaginary number that was not there. So that is one of the reasons we will now need to add this function. It should check the value that we want to withdraw and see if we actually have that value. Yeah, so then we can actually check the amount if it's available. It's true that it's saying that it's true because it has actually created an arbitrary value. It has an overflow error. So that's why it's like saying that the value that we have in the buckets is there. So that's the reason for adding, another reason for adding interfaces. So to avoid such case scenarios. Just a minute. So we will add the interface, our interface here. So we will add this contract. We can either create a new file, a new file and give it the name regulator, or we can just create another contract above the contract bank. Yeah, so those are the, so also the arrangement of the contract matters. So if an abstract which is going to be used by the main contract should be defined above and then used below. Yeah, so if you want this function, like the deposit function should come first. Always, every time you create a bank account, the first thing you do is you deposit. That is the trigger action. You have to deposit before you start withdrawing, and then balances comes after you have withdrawn. So the functions have to kind of follow each other in a chronological order. Yeah, so we will now introduce our functions. So it's an app, like we have said, interfaces are similar to like abstract contracts. They are limited to what the contracts APIs can represent. They have restrictions, cannot inherit other contracts or interfaces, cannot define constructors, and cannot define variables, and cannot define structs, and cannot define enums or booleans. So for more documentation on interfaces, you can go to Solidity documentation. I'll share the link. Yeah. So we will define a regulator. This one is for regulating the amount, the amount or the balance that we want to use. Before that, I should have added this one there, because we already have okay. Let's just define the interface. So we interfaces have a keyword that is normally used. Interface is a keyword for defining an interface. So our interface is called regulator. So regulator will have a function called check value, with the new int amount of 25, and it's an external returns a value of a boolean. Another thing, if you have noticed that when we added this value 256, this is what the characters are like this a big number. Now this one becomes a big number. Yeah, so then remember your semicolon, and then so remember your semicolon, and then we have another function.
Sorry, question.
Yes.
Yeah, like now I'm seeing the use of two words, external, public. You got it. If I decide to go with public, isn't that the same thing as saying external?
So external, like I've said, external means that this function can be used externally, like it can be used in other contracts. But internal functions, like this one, we can make it internal. But by default, it's an internal function. By default, it's internal function.
No. What I'm saying is the public, before the internal function, there's public. That means that it can be external.
Yeah. There can be public functions that are external.
Okay.
Yeah. Those public functions that are external. So public functions that are external can be used in other contracts. In other contracts. They basically define the same logic. You want what how can I say this? It's like a torch. If you have a torch,
Yeah.
you can use it inside your house or outside the house.
Sure.
Yeah. So
Good.
that's how those functions looks like. They have multiple purposes in different contracts. So you can like call them and use them in other contracts, and import them and use them in other contracts. Yeah. Yeah. So
Okay, cool.
yeah. Then we have another function which is also an external function that is for checking loans. Returns a Boolean value of true or false, and then don't forget your semicolon. So we have actually defined our regulator. So the way we normally call it, or the way we just say bank is regulator. Bank is regulator, and then we can be able to do that. Now remember we removed the override here. Remember we removed the override here and here. So we need to override these functions so that they can be used by, so that this one can be able to be used. And yeah, so we need to add the override there, and another override there. So these are some of the keywords that are used in Solidity. Most of these words are keywords used, so they are reserved for the compiler. And then remember we also want to like check this amount so that the contract does not repeat the mistake that we have done, create an arbitrary value or a value that does not exist in our smart contract again. So we need to add this function and check if the amount is actually greater or equals to what we have in our bank account. So we will add the if statement, if check value, and then pass our parameter, which is this amount, and then we will just pass the logic there inside the if statement so that we can now check the value. And now we have a complete function. We have a smart contract that has actually solved the overflow error, and also we can be able to like check the value that we have in our bank. So let's just go back and redeploy our contract. Oh, got so many. Yeah, so let's redeploy our contract again, and we will have to like input the same amount of money that we had initially started with. Deploy our contract again, and then confirm the transaction, and we will wait for it to be mined. Awesome. So we have our contract below there, and then we will do another deposit again. What we deposited 100 shillings, and we do another confirmation of the transaction and wait for it to be mined. So we can check the balance. So it's 1100. So we can try and withdraw again. We can withdraw a bigger number like 3000. see if our transaction will go through. So that we can be able to know if our logic is working. So let's check the balance. So our balance is still the same. So our contract is working as we intended. So our balance is still the same, and the transaction has, okay, even if it says that the transaction has been confirmed, there was no withdrawal. There was no withdrawal that happened. So there was no withdrawal that happened. So our contract is working quite good. So let's try and withdraw something like 30, 30, 30, 30, 30. Yeah. So just let's try and withdraw some 30 bob and confirm. Let's wait for the transaction to be mined. And then we can now see if we have a balance, and our balance has reduced. So our contract is working. So there are some few things that we can actually add in this contract. Like it should, if the value is less than, if the value is if the amount is bigger than what we have, then it should revert and give an error message saying that you cannot withdraw this certain number of coins or money. Yeah, we can also check the value. If we can actually check if we have the a value, and yeah, we truly have like 100 bob in our account. We kind of have a value that we can withdraw. Then we can try and we can also be able to receive a loan. So this one we will build on top of this, the bank contract. So tomorrow we will do something else on the same. We will kind of add something on top of it, and yeah. So that's it on the bank smart contract. And then I will redo the demo on the borrowed one. Yeah, it was such a, yeah. So I hope this one was a little bit simple. Yeah. Hello. Any question? Any question? Any?
Yes,
No
I
question.
have
I
a
think
question.
Yes. 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 Go ahead. Go
I
ahead.
have a question. Before the first session, you were talking about DAOs.
Mhm.
That was in crowdfunding.
Yeah.
And now, recently, I was in a group that converted into a DAO. So I think I'm losing meaning in what exactly is a DAO and operations of a DAO. Because it turned like a WhatsApp group into a DAO. So I felt like whatever, it's not really what a DAO is supposed to be.
They converted they converted a WhatsApp group into a DAO.
It was actually a Telegram group into a DAO.
So
Yeah. I think I've not really understood the operations of a DAO and when you're talking about cloud funding.
okay, decentralized autonomous organization. These are organizations that are decentralized in nature, and the DAO that I was speaking about is the first DAO that the one that I introduced in the DAO attack. Yeah. So that DAO, they had a way that they were doing crowdfunding like Kickstarter, like this Kick Kickstarter. So people would actually be able to fund. This one is more centralized. It's a more centralized way. So if you want to kickstart your business, you need to like create an account here, and this transactional mainly not they are never recorded on anywhere. That the process is not that much transparent. But for the other DAOs, most decentralized autonomous organization, or an organization that was called, they had created an organization which looked like the Kickstarter, but it was decentralized. It was decentralized, so people could be able to like create their own project there, and then they are able to fund. Because one thing about Kickstarter is that Kickstarter, people have to like show show themselves to be trustworthy. But with a DAO, it was with that DAO, it was open for everybody. But another thing about decentralized autonomous organization, people can decide to like decentralized their operations, So some of the companies like Tesla, they put their ledger on Bitcoin, meaning that they decentralized. It's not fully decentralized, but the transaction part of the organization is decentralized. Yeah. So that is there is a lot of meaning. There is a lot of meaning, but I was trying to like say that explain that you can be able to use crowdfunding in decentralized organization. Currently they are less there are less crowdfunding that are doing that have been created on blockchain because of the recent schemes that we have had. People creating a crowdfunding project, and then later on they run away with ETH. Yeah, they run away with ETH. Yeah. So I don't know what they meant by decentralizing the organization, but maybe I don't know which part of the processes they decentralized. Yeah, maybe you can elaborate on that, if they have created a smart contract to like decentralize their operation or something.
It was a community.
Mhm.
I think you know it. It's run by David Gitonga and Matu Alex. I don't know if you know the two.
I know David Kitonga, the one from Bitcoin KE.
Yeah, exactly him. So
Yeah.
we were having a Genesis group on Telegram,
Hmm.
and then they converted it into a DAO. So
Hmm.
they were, I think they are yet to have a smart contract, because they were talking about having a pool where
Hmm.
people can contribute, and everything. Now we can have voting, we can vote, but
Hmm.
now everything is done through a smart contract.
Oh, okay. I think I don't know. I haven't heard about their project, but I'm not sure about what they are creating, so I cannot be like in any position to like speak. But if they are looking forward to creating a smart contract where they can people can be able to like vote and participate and have say in the organization, and have share of that particular organization, then yeah, something that it's possible, something which is possible. A company which is actually more decentralized, or which has a say in the communities, the Zero organization. So Zero have that part where you, if you own a coin, you can be able to like participate in in the voting process, and you have a say on what you want the community to do. So they are more of community driven, and I guess I don't know whether they are trying to follow that process. Yeah, yeah. But the smart contract part has to be part of it. The smart contract has to be there so that the organization actually becomes decentralized. Yeah. Most of those processes should be on the blockchain. Yeah.
Okay.
Yeah. So that's something that I would want to see. Something that I would want to see. Yeah. So yeah. Yeah, that's it. In case you have another question and or comment or observation, you can drop it. You can drop it here.
No, I think hello.
Hello.
With this simple bank contract, we can try it out. Then tomorrow give you a feedback.
Okay. Yeah.
Since we have our MetaMask already funded, we just go to the site and try to deploy it.
Yeah. Yeah. So
So at least one day,
yeah.
the language is English. So we just learn the syntax and improve on the English. That is all.
Yeah. Yeah. Yeah.
Okay.
It's actually simple and easy to like understand. And unless now when you start dealing with math and a lot of English.
Which environment is this?
Yes, this one
Which
is
environment?
this is the limits IDE. Limits IDE. It's online. I haven't. I was hoping
Can you
to.
share the link?
Yes, let me just share this link. You can use it. Limits IDE. I was hoping today we could do the there is the link. We could do the setup and tomorrow I think we can start with the setup. I help you set up your environment, that is the VS code and the truffle and yeah, so that tomorrow we can at least do something with truffle. We can see something, we can do something with truffle. But meanwhile, we can still be doing this. We can be doing practice with limits IDE. Yeah, yeah. Because in our next what do you call it? Our next class that will be on. Let me see. Our next class will be on introduction to Ethereum token. And I want us to have under it will be more continuous. Like it will be a continuous. We will have a continuous interaction with code. We'll have a continuous, like it will be like a marathon now of coding, because want us to like have to I want us to deploy a simple coin that does like with simple functions and yeah, or not even a coin, but we can even deploy something different. It's not necessarily a coin that has that we will have covered a lot of clouds and events such that yeah. Yeah. So that we will have like done a lot of the most like we will have to do like something to do with error handling, how we can handle errors in Solidity, how can we emit events on Solidity, and function modifiers. So I think tomorrow we will do function modifiers and contract inheritance. So we have actually done contract inheritance. I've done contract inheritance. So this is the contract inheritance, and we have also done interfaces. We have done interfaces. And tomorrow we will try and do something to do with function modifiers. So function modifiers are special type of function called function modifier. You can apply modifiers to functions by adding the modifier name in the function declaration. So modifiers are most often used to create conditions that apply to many functions. So like only owner, like the one we had for the bank, whereby we are saying that only the chairman can approve or can add the proposal names. We will kind of create a modifier that does that. Instead of writing a function, we write one function that can be applied to other many function. We just call that modifier anytime we want to use it. So most of the time it's added at the end, like here. So like we can say the only person who is supposed to like deposit, we can say like only owner of that account, or only owner of this particular contract can actually deposit. If you are not part of the ownership of this account contract, you cannot be able to do that. So those are modifiers. There are different modifiers with different functions. And yeah, so that's it. And this actually concludes the end of our lesson today. And yeah, we are going into the deep. Yes, Ambrose.
No question, no question. It's okay.
Yeah, so we are actually going into the deep. And yeah, so far so good.
Yeah. Yeah, so far so good.
Yeah. So just practice makes perfect. And by the time you know it, you are actually looking for a job as a smart contract developer. Yeah. So I'm also looking looking to invite somebody who is actually who are people who are working in the blockchain space here in Kenya, and also in different countries, to come as guest lectures, and yeah, to give their testimony on how the journey has been, such. Yeah, so like a motivation to like see that we are not just alone. Yeah.
Yeah, that would be great.
Yeah.
That would be great.
And also to actually talk about the career opportunities which are available. Yeah.
And
Yeah.
that would be very great.
Yeah.
Thanks.
Okay. Sure. So let's have a good evening, and enjoy the rest of your evening. Yeah.
And you
So
too.
yeah,
Thank you.
in case you have a question or clarification that you want, you can always contact on WhatsApp. And if you have a problem with your code, you can always I have a Google Meet link which is actually dedicated for that. I always share with the guys that I work with, we because we work remotely, I created a link whereby we can, that link is dedicated to like helping solve common errors, and yeah, so the link is always ready. I just share it, and then we can always do that. Yeah, we can always have a go meet
Yeah,
and solve the errors together.
okay.
Yeah.
Okay. Okay. Thank you very much.
Yeah, so enjoy the rest of your evening, and have a good night, and a great day tomorrow. Yeah, bye.
And you too. Thank you very much. Bye.
You too.